ready to get started. So of course, we're running late, and we're going to stick something else into the agenda. So before we get started, or the way we're going to get started, is I would like a representative of each of the brainstorming sessions to just come up, a couple of just a soundbite of the outcomes of the session. So did each of the brainstorming sessions choose a representative? Do we have volunteers, or am I going to have to call on the audience? Michael Adams, who is the representative for the finance section, and will they come to the table or the podium?
No, we push them to be.
Finance, okay. Michael, take it away.
I wasn't expecting this. So we had a very interesting discussion. There were about 12 of us around a table from different points of view and stakeholders. And it's quite difficult to summarize. I mean, finance is part of the ecosystem that makes this transition towards zero-emission shipping happen and is already playing a role in it. The Poseidon Principles set out the intention for the signatory banks behind those principles to fund sustainable shipping and all the different levels going towards zero emissions, and is well underway towards achieving those kinds of goals even after 2 years. Paul, what was it? You have 200 billion of financings of capital that wasn't there before, really, in that space, and some 28 organizations that are reporting, not just making a commitment to say, yes, we'll do this someday, this is a nice thing to sign on to, but actually transparency at the end of the year, you can see what they're doing. So that's significant. And these are not just the European banks that helped get it going, but major Japanese banks are involved, and American from all over the world. We talked about the different other participants that are investors in green shipping, and some are not on board yet, like the leasing companies from China, but that's a work in progress, and all the different aspects of how ESG and emissions are becoming, in fact, a currency that is identified, has value, and is going to be very much part of the trading and financing solutions. I think Maddie's pulling the
No, I was agreeing with you.
Okay.
Yeah.
We covered so many things, it's really quite difficult to... This is a highly volatile industry which over time, with clear and concise regulations and financing behind the solutions that the industry can come to agreement on, will become less volatile and it will become less numerous. This consolidation's been underway for 10 years and now it's going to be accelerating, and financing is part of that. So these are exciting times. There are reputation risks. We talked about the whole ecosystem of sustainability too that people are going to be looking at, not just emissions. And that another element that's going to be strategic investors in this, financiers of this transition, are the oil and power companies, the energy companies that are going to have to become clean energy companies. And that is a factor that really hasn't been measured in yet. So also 85% of the capital needed to make this transition is going to be on land-based investment, so infrastructure financing and the financing of those supply chains, whereas most of what we're talking about here today is zero emission at the point of use. Yet the whole chain is being looked at by the traditional financiers as well as the new players coming in. That's our summary.
Okay.
Yeah.
Thank you very much, Michael.
And you'll hear much more tomorrow.
Yeah,
morning.
much more. But I think
The big thing for me is that emissions become a commodity, and I think they become a negative commodity in a negative sense. And so, and then next is from the systems. Who do we have representing? There we go. Okay, welcome.
and if you might introduce yourself, sir.
Yeah, so I'm Jacob Armstrong, Transport and Environment. So I was volunteered with all my desire to come up. So yeah, no, we spoke about a lot of different things about how energy efficiency measures are going to be really, really important, as well as everything else. There was obviously lots of different barriers to it. The tech is probably not one of those barriers, but there's different things like finance, difficulties asking financiers, institutions to provide the capex for those things, even though maybe they can give you kind of fuel consumption benefits later on. We talked about the market, how the market is probably there. The clients are now kind of, at least in public, demanding cleaner shipping, but whether they are actually willing to pay more for it, that's maybe a different story. Then in terms, tech, I suppose there was lots of things which I can't read at the moment that we wrote down about tech. But yeah, the tech is there, and there's lots of very innovative things that are happening, and the AI will be very important in this, and things about tracking your data consumption, doing lots of different things about it. Lots of exciting things there, as well as kind of speeds and maybe going a bit slower and showing how that can actually save you so much more fuel, as well as planning your journey and things like this. But the thing we all coalesced on towards the end was in terms of the policy ask, that we really, in order to make these energy efficiency things profitable, that we need policy there, and carbon pricing came out. The industry came out all together hand in hand for carbon pricing, especially EU proposals. So that was pretty much it from our side.
And summing up, supply chains is
Our very own executive director from Zero Emissions Maritime Technology, John Butler.
Right, thanks everybody. Yeah, we had a really good conversation over on this side of the room. I guess a lot of what we're talking about is what the supply chain is going to do and how that can expand in order to ensure that we're getting the right utilization and demand for hydrogen itself. Obviously, a lot of discussions were around how we can build up sort of, disconnected or identify, sort of locations for hydrogen production in different areas, and really try to identify the locations for the actual hydrogen production itself. Well, a lot of discussion turned around energy islands and the use of infrastructure in existing locations. So when you look at things like that are happening in Northern Europe, you've got likes of Orkney was touched on, Shetland, that was using existing infrastructure in order to build out energy islands there. In Denmark, they're building their own man-made islands in order to identify sort of the location for hydrogen production. And it's really about that decentralized aspect to ensure that we're getting the right volumes of hydrogen when we need it and where we need it. Obviously, a lot of analogies went to renewable energy as well. Obviously, when we're looking at green hydrogen, it all has to be produced from the same location. So it's identifying the renewable sources and what they look like, whether it's going to be onshore wind, offshore wind, floating solar, and the various different elements within there. So again, right at the beginning of green hydrogen is obviously going to be sort of the renewable source of energy, and ensuring that we have the supply chain that is, I guess, co-located in order to ensure that we get that full end-to-end solution for the green hydrogen supply chain. And then lastly, again, a bit like similar topics, we looked at the digitization side of things, and really a lot of what we're talking about is the technology that's there needs to have sort of support from different parts of the industry, where you have digitization in order to create efficiencies. Those efficiencies reduce your overall fuel burn, and that allows you to have the volume for fuel that you're getting from the likes of green hydrogen. So I think that was most of the points. Anybody at our table want to shout out anybody else? Anything else? Stunned silence, as often when I speak, so I think that's it.
Great. Well,
we've got 6 more sessions, 5 more sessions to go, so I think we've got time to work it out. So we have what am I looking at here? Yeah, Benjamin Lachaptrois was unable to join us. And so Thomas Tronstedt has kindly stepped in his place as the moderator for the upcoming session. There you are. And so I'll let you introduce your speakers, Thomas. Thank you. And thank you.
Thank you. And so we're moving on. I would like the speakers in the panel please to come up. I'm happy to say that we are in for a good treat now. We have some splendid representatives from the industry, and I hope we also get US with us from Joe with virtual presentation. We'll see if that works. But in the meantime, let me introduce very shortly. We have two representatives from the fuel cell industry and one from the storage tank industry, to put it that way. So we're going on board a vessel. We are looking at the systems on board. And I have been working in the fuel cell related industry or business or activities the last 18 years. And people ask me then often, so fuel cell, I mean, they have been developing this for so many years. And we say that they are kind of, but still, I mean, are they here? Are they ready? What? And what most people don't know is that the last 18 years, since kind of the boom or the hype that was around the millennium, tremendous things have happened on the fuel cell side. So without much kind of notice of it, the fuel cell industry has managed to reduce enormously the cost. So we are taking out kind of the potential of all that could be done related to manufacturing, the cost of producing everything, except for the mass production. But the cost of the materials, how to make it simple, everything else has been done there. It has improved reliability greatly. It has improved lifetime greatly. And we will now hear more from these gentlemen on their systems. I know that they have been asked not to give too much details of their kind of product line as such, but more on the overall issues. But I hope that they get some few lines with and then I'll come back to the tank system, which is, most people don't know that, but because in the shipping industry, gaseous fuels has not been the core focus so far. We tend to have focus on liquid fuels, clearly. So what we don't know too much about is really that there is a large and enormous industry around pressurized gas. And there are so many products there, and Hexagon being here today is going to show us some of that. So without any further ado, please have Johan Burgen from PowerCell.
Thank you. Thank you very much, Thomas. And also for those who doesn't know, Thomas, you actually started the fuel cell journey quite some time back in Norway. So you have some experience in actually installing fuel cells. Or was it 15 years ago?
Yeah.
Yeah, something like that. So we're gonna not have a repetitive session here. So I'm gonna bring you through some why, zero, and just an introduction to the fuel cells. And then Jogchum is going to bring you on the more of what is good to know, how to size things, more the application, what to consider going forward. So basically, the situation, you've been reading that, right? This is the situation we're in. I'm advocating for this company in Gothenburg. They're utilizing AIS data, and they're using an application on the AIS data, so they can they know each vessel, how much power is installed, how fast they're sailing from the AIS coordinates and so on. And then they calculate the energy used in these vessels. This is all ships above 500 gross tons. And this is the development since 2012. You can clearly see the COVID effect, the drop in 2019, but the pickup is drastic. So we have a 10% increase in 1 year in carbon emissions. So it's quite interesting where this leads us. So if we go in this direction, this trajectory is leading us to 200% increase by 2050. And the whole point was actually to reduce by 50% compared to 2008. So we have to really get down to something. So the scenarios could be, if we do it now, we have to reduce by 2.6 roughly, year on year. If we do it in, let's say, 2030, that's a mid-step for IMO, implementation of indexing. Actually, it's going to be all close to 5% annually, but it's going to be, the net is going to be almost 7.5, right? because we have to mitigate the economical growth. That's the baseline we're traveling on. So basically, this I think would be a reasonable scenario. In 15 years, it took, Thomas again, it took 15 years for LNG to take us to where we are today with LNG, and to have an offtake in the business, and to have some ships out there, and the bunkering is now working, and we have some supply chain in the industry. And that's a net reduction of close to 10% every year if we start now with 0 emissions. Take that in for a sec. 10% every year. Hasn't been done, but we can do it. We have the solutions. We know that. They are out there to grasp. So, the fuels. This is a complicated chart. It shows a lot of things. Water to hydrogen through a renewable electricity. Carbon capture, if we are not using feedstock from every kind of dubious sort of feedstock source, like rainforests and all kinds of carbon that you can get out there with dubious cycles of carbon. We actually have to do the direct capture, right? Through the synthesis, we can create any future carbon fuel, what we call e-fuels. So the e-fuels would be hydrogen, ammonia, e-methanol, and e-gas. That was e-methane. And of course, the technology for doing those fuels are not equally mature. Direct capture is not really demonstrated. We have carbon capture today. We're pumping back to the drill hole, the carbon. Equinor has done that for 15 years. They've proven it works, but they have not captured the carbon from the atmosphere. That's a big difference. So if we're going to do this, anyway, we're going to end up with a fuel that we either burn or use in a fuel cell with further possible emissions if we are not using the hydrogen. And if we move back, can we afford releasing the carbon again? I don't think so. We have to bend off the curve 10% when we have implemented this. And methane has a lifetime in the atmosphere of roughly 10 years, and then it breaks down to carbon dioxide. Then it stays there to capture. So, just a few words on ammonia. Ammonia is on the table. It's been mentioned a few times today. I just Googled this, so for anyone to understand the complexity of ammonia, it's corrosive. You can die from inhaling it immediately. And it's harmful to aquatic life. So if this is a fuel of the future, you have to decide for yourselves. But I think it would be, I would consider or reconsider. The thing is, when you're doing safety assessments through the risk-based assessment, you're actually looking at a single failure and has to be mitigated by some kind of mitigation method. So if there is a hydrogen leak, you have to have an ignition source on the same time. With ammonia, you just need one thing, and that's a leak. Then you have a catastrophic event. And I'm not sure what class has to say about that, looking at the further ado with the regulations, right? So water to hydrogen to water, that could be a very uncomplex future. So, marine fuel cells, do they exist or not? What do you think? Yes, they do. Of course they do. And to make this possible, and Daniela was into it, we have to use ships that are extremely much more efficient, so using sails to reduce the energies needed. We need to be able to maintain the speed, the sailing speed, so the cargo owners are satisfied. And the port calls are done in according to time. And we have to introduce zero emission features on all vessels, not only the short sea, the easy ones, the short sea ferries, also the deep sea. So I will show you some examples of that. Actually, we are, at PowerCell, we are involved in this project right now. So we are making a 3 megawatt fuel cell plant being installed on a vessel. I can't tell you the details of it, but this is the size of it, and it's going to be delivered, and it's going to be installed. And it's going to be operated and filled with liquid hydrogen. So this guy is demonstrating, this ship owner is demonstrating that this is possible to do. And there are many out there conducting projects as we speak, right? So a reefer container solution for deep sea shipping could be possible. When they are loading reefer containers, their need for auxiliary power would increase quite a lot. So they're actually looking for a solution that they can load a few ISO containers of liquid hydrogen, combine it with a fuel cell, and then off to go a few weeks, actually, of reefing this, refrigerating these containers using that power. So that's where these guys can start, right? And then on top of that, fuel cells are highly scalable. At PowerCell, we are using 200 kilowatt increments, so we're just starting from that point and scaling them upwards. And then you see on this picture a few interfaces. I will not go into those details. You probably will get that session with Jogchum. But you see there's not just the plus and minus as on the battery. There are more interfaces needed. You have cooling, you have a DC switchboard, an electric switchboard on board, and ventilation for safety and so on. So the concept we have gone about with just promoting a bit on what we are doing, we are looking at a fuel cell that is modularized. So this is actually power by the hour in its usage. We are modularizing it, so we're swapping out modules for the best possible operation. So you don't have to care about so much the operation of the fuel cell. You're actually just paying for the running cost of it. It's made in respect to safety. So we're actually ventilating the fuel cell space and making it safe to run. So, and we're actually testing it at the moment. So as we speak, actually the functioning testing of these units are carried out. We are pushing power through the grid, roughly 200 kilowatts on this one, through a switchboard, which is on the right side of this picture, and then through a transformer out on the grid. So we're boiling whatever water, coffee, whatever you have in the surroundings. We're in Gothenburg, where we're positioned. And this is what it typically looked like in a larger installation of a fuel cell. So quite smacked with a lot of HVAC systems, piping, electrical gadgets, but it's all doable, and it's being done as we speak. So just to sum it up, hydrogen and fuel cells are there. We can use them. We can use them in many segments today. Ro-packs, ro-ro ferries, even container vessels can use them as reefer auxiliaries. So I leave it to Thomas to take it on to the next presenter and go to the details. Thank you.
Thank you, Johan. So you will understand there are different ways of integrating the fuel cell on board a vessel, and PowerCell clearly comes from the point where a lot of the fuel cell manufacturers come, having worked mainly with automotive solutions so far, but now transforming that into marine segment. So another way of looking at it is what Nedstack will be speaking of, I'm sure of. So Jogchum Bruinsma, he is perfectly the man today, application manager. Please.
Thank you, Thomas. Yes, indeed, I'm application manager maritime at Nedstack Fuel Cell Technology, which means I'm responsible for all of the maritime applications that we see, the classification, societies, questions from ship owners, naval architects, everything which has to do with maritime passes my desk, and frankly speaking, I have to do a lot of that work myself, which also makes me sort of an expert now. I've been doing this for 3 years, and I have a background in the shipping industry myself. I've been working with Boskalis for over 8 years. So knowing how the maritime world is working, how yards are working, how things are doing. And that's what we try to do at Nedstack, is to work together with the sector, with system integrators, to bring the best of different worlds together. And we've been doing that for over 20 years now. So we started out in the late 90s developing our own fuel cell technology from an industrial point of view. Our sister company or mother company where we started was called AkzoNobel, a chemical company who said, okay, we have big industrial plants producing hydrogen, and we are delivering all kind of materials to the fuel cell industry, but there's not something in that fuel cell industry that we would like to have on our industrial and petrochemical plants. So we started developing from scratch our own fuel cell stacks, specifically designed to last, as well as the fuel cell systems. And that's given us a proven track record of power plants, industrial power plants, of which the first we built in 2007, and it's been in operation until late last year. So it's been operational for more than 10 years. We built already the first megawatt power plant back in 2011, and also the largest power plant on PEM fuel cell technology was already built 5 years ago. Just to show you that this technology might be new for the sector, but it's been quite well developed in the stationary market, also on very high power applications. So just for those who've never seen a fuel cell or know how it works and how you get from water to hydrogen to water, you see here on the slide how the fuel cell actually works. It's a membrane technology, it's solid state. What happens is that you have a membrane. On one side you have hydrogen, and the other side you have air, and the oxygen in that air wants to react with the hydrogen. The hydrogen splits because of a catalyst which is on that membrane, and it turns into protons and into electrons. The proton exchange membrane, can go through that membrane while the electrons cannot. And those electrons, they form an electric current, and at the other side of that membrane we bring everything back together, and then you have H2 and oxygen O producing pure water. Those fuel cells, which is just 2 cell plates and 1 membrane in between, just deliver maybe up to 1 watt each. But if you start stacking them, you create a larger potential difference, you create a larger current, and you can get up to powers of multiple kilowatts. In our case, if we combine that everything together, you get up to 13 or 14 kilowatts, but also we've seen automotive fuel cell stacks are ending up at 100 kilowatt stacks. So I hope this is a little bit readable. It's small letters. It's a bit more detail on what Johan just showed. The stack itself doesn't do anything. The stack is a reactor. If there's no fuel in, if there's no oxygen in, nothing happens. So it seems a little bit like a battery. It's the sort of same technology. It's solid state, but nothing happens if there's no fuel. So we need to bring that fuel to the fuel cell stack. You need to bring air to the fuel cell stack, and you need to create a great environment for those protons, for that electrical or for that chemical reaction to take place. And that we do by humidifying to keep everything nice and wet in there, warm. It needs to operate at a certain temperature, and we're also helped by the fact that the fuel cell is creating temperature or creating warmth and heat by the reaction itself. So you also need a cooling water system to keep that heat and the temperature at a specific point. The fuel cell then generates a variable DC voltage, which differs with the load. The higher the load, the lower the voltage gets, and that means that you will always need some kind of power conversion afterwards. On the positive side, you need this extra component, but you can make any grid you like. You can make a DC grid of 1000 volts or 700 volts, or if you want to be on AC, it can be 400, it can be 690, it can even be 10 kV if you want, on 50 hertz, on 60 hertz. It could even be that you change it throughout the system. If you are in one port, you need to go to 60 hertz, it's possible. Of course, a lot of other things are gonna go wrong, but if you want, you can do it. What we call this is the balance of plant. So you have fuel cell stack, you have a balance of plant, and that includes the cooling water around it. That includes all the air humidification, the handling of the air, and you need an external power to run the pumps. So we will always be looking at some kind of hybrid solutions, because like any diesel generator nowadays, you can't start them without a battery. And the same yields for fuel cells. So just one step back, if you look, okay, where do I see this fuel cell then? If you look at the overall zero emission scheme, you have an energy source, and you can make pure hydrogen from it in the purest form, compressed or liquid. But there's many other hydrogen carriers in development at the moment. We hear a lot about ammonia, for instance, can also be a hydrogen carrier, or methanol. But there's also a lot of development on organic hydrogen carriers, on powders, on all kind of storage devices to store the hydrogen on board. And by reforming that, by cleaning that, you get pure hydrogen, and you can use it in a fuel cell. If you want to use it, for instance, in an internal combustion engine, or you want to make it really zero emission, and you start with methanol, you also need after treatment, residue storage on board to really get to true zero. So in our perspective, if you can stick with hydrogen in its purest form, you don't need all of that, and you will gain on efficiency, on space, on locator. And then of course you can use the electricity in your main switchboard, and the heat, you can use it to release the liquid hydrogen, use it to heat up your accommodation, your storage holds, make good use of that heat as well. And that's where we get to how to design a vessel, and it starts with your mission profile. Other than maybe now, where you can get a lot of bunkers everywhere, you can sail from A to B, and it doesn't really matter how long the trip is, you can take a lot of fuel on board. If you are switching to zero emission, if you're switching to maybe starting with batteries or fuel cells and hydrogen, the first step is to really pinpoint what are you doing with your vessel, and can I pinpoint that to one certain location? And possibly you can. It's possible that you are operating in a certain range where you never leave that area. So the amount of power that you need at which time is really important to pinpoint what you need to do. If you found out, okay, this is my mission profile, this is the amount of power I need, this is the amount of energy I need for that same trip, the next step would be looking into how you would integrate that then in your ship. And I said it could be AC, it could be DC, it could be hybrid with batteries, it could be maybe in your application you need supercapacitors because you have very high peak loads, or you may end up with a different fuel cell as well to have base loads. You can just vary that to fit your application, looking at what you really need to do. And then if you have found this, the next step would be integrating that into your vessel. And this is what we've been doing in the sector all the time. But we need to start a little bit over again and design. But I think we as a sector are able to do this. We know how we do with batteries, we know how to do fuel cells, or how to do cooling water systems, fuel systems. So we will also be able to put fuel cells on board. It's not rocket science. And of course, we touched upon it this morning. The next question is then how about regulations? Well, regulations are in progress. There are guidelines available from any large classification authority on the use of fuel cells on board. Not so much on hydrogen, but on fuel cells it's already there. The IGF code is being modified. The CESNI is making rules for inland shipping. So it's in progress, but the rules are not there yet. But then, until then, you just use the risk-based alternative design method, which is also part of that regulation, which is saying, okay, what I want to do is not covered by regulation, but I use this risk-based design method to show that it is as safe as possible. And this is something that if you start from the beginning and you involve classification, the class authority, and everything, it's not that much additional work. It's a pain in the ass because we're not used to it, but it's how a lot of business is already done outside the maritime industry, where you start with a contract of 1 page and you will have to conclude every step of the way that you're still meeting those targets. And then I think the best concrete step is to start working on those concepts. No one in the shipping industry wants a fuel cell. They want a ship that can sail and do their job zero emission. So we need to develop those vessels. So we can also show to the people who are supplying the hydrogen that there is a demand if they would start building infrastructure import. We've been doing this for different sectors. And then as a second result, it doesn't stick with just concepts. Real projects are already out there. And we hope in early next year to start sailing with the first inland barges in the Netherlands on a commercial basis. So we're not talking demonstration projects anymore. We're talking about real contracts, about real delivery times, and about real commercial operation of vessels. So my message today is it's possible, we can do this, the technology is there, and why not put your vessel, your port on that last part, and let's make it happen. Thank you very much.
Perfect. Thank you very much, Jogchum. So we're moving from the fuel cell to the tank side, and I'm very pleased to introduce Håvard Stave from Hexagon. That's a world-leading company within storage tank solutions.
Okay. Can you hear me? Yeah. Okay, my name is Håvard. I work for Hexagon Purus. I'm based in Ålesund in Norway. I'm focusing on compressed hydrogen systems on boats. We are not only the storage tanks, but also trying to help the different ship designers and ship owners how to integrate it onto the ship. And I will give you some impact and on some stories about some hurdles that we face in our work. And please bear with me for a few minutes. Now, basically, that's what we do. And what I'm trying to give you some story about today is that it is not enough to think about it. You have to actually try to do it. So overcoming the hurdles that we see around is some of the most important things that we try to do. A lot of what we are trying to do is based on components, technology, bits and pieces that are already existing in other industry areas. Whilst it's not so much done in maritime so far, there are a lot of cars. We spoke the word about rocket science, although we made tanks for rockets. This is not rocket science, really. This is components and technology all around us, and it can be used, although we don't know everything that is needed to integrate it into the ships. Some of the challenges I feel in my everyday is that some of the legislation from the different technologies and different markets are not in sync. So the legislation which is on land for hydrogen production is maybe good for the production on land. We have distribution legislation, how to distribute it safely and in a nice manner to the quayside. And then we have to bring it on board to the ship. And while we are on board the ship, we need to make sure that the people who is going to operate it are well trained and well prepared to take care of it. This is not included in engineering training today. So the officers and the juniors, they don't have necessarily, from the basic training today, they don't have this experience. This technology is less than 20 years new. So we have to think about the different aspects throughout the value chain. What I'm trying to say is that we can learn a lot from other industries and other markets. Although we are a bit delayed and late maybe in compressed hydrogen gas applications in maritime, there's a lot to learn from other industries. And it works. Maybe not out of the box, maybe not taking care of every concern that we face in the maritime ship design, but let's try to find out and fill in the missing gaps. We find the numerous handover hurdles in when we're trying to integrate it onto the ship. So in every handover, we face different challenges, different insurance companies, asset owners, different rules, regulations. Who owns the asset? Who's responsible for the asset? Who's responsible for the safety? And who can certify the training? There's a lot of different hurdles. So also from a components supplier point of view, it's a bit of a challenge. As soon as we come on board the ship might be quite complex, but at least from the minute we climb on board, we have less and not so many different legislation guys to speak to. But this is where we have at the moment least or not enough guidelines to follow. So we are trying together with partners and other companies to work together with DNV, ABS, RINA, Lloyds, the maritime authorities and everything to find out how can this be done in a nice manner so that we can learn, how can we improve ourselves, and also how can we teach the youngsters who's climbing on board to take care of these things. Because it will happen, and there's also risk for accidents if we don't do it correctly. Here's an example of small boat. It's Hynova. It's a French small yacht. Okay. She has 3 hydrogen cylinders. The boat is less than 15 meters long, which means that it's a leisure craft. A leisure craft which each of us who would hesitate if we were in France and we were hiring a tourist boat or a taxi boat to go along in Marseille area. Would we hesitate? Or would we dare doing it? I would go on board. This is checked, this is okay, this is an automotive solution on board. It's much easier to do because they comply with those regulations, which is compliant for the bus, which is transporting your kids to the kindergarten. Why do we not accept it in a professional maritime ship? But we do accept it in leisure craft, prototypes, demonstrator like this. This is a Norwegian small day cruiser based on some of the same technology. It's still a leisure craft. Not everything is solved from any of these. These systems will explore the new technology. We're trying to learn from the existing market, from automotives and other business. Afterwards, I guess we will learn from Joe Pratt, hopefully, that he was heavily into this design in America. This is the first big professional zero emission compressed hydrogen gas vessel. And at the same time they were doing the job in America, US Coast Guard is in parallel developing the rules, which is quite impressive that they do. And they do it in respect for the industry, that some rules and regulations are necessary. Okay, so unfortunately it takes a lot of time to get it done, to get it compliant, but it is important that they do. This is an example of a fixed mounted cassette, where we can use the same cylinders as we can use for transporting hydrogen on land in America. We can use it as a fixed mounted cylinder bundles in a ship, just as an example. We can use much of the same components. Each of them are all certified in the business. They withstand corrosion and sea and salt water, no problem. But there are no fixed class society rules. So for the financial people who's doing the economic risk calculations, there's nothing for them to measure against. So how can they measure and be sure that from an investor point of view, this is going to work and it's going to be safe for the next 15 years or 20 years? So unless we have a better legislation and better training and better understanding, I am sorry, it will be some of the guys will have challenges, because earlier we heard about collaboration. I think we have to be quite collaborative, all of us, to make sure that we are raising the skills together. This is an example of a piping diagram, which is quite easy, really. It is just a cylinder with some valves and so on. Doesn't need to be too complex. The thing is that if we do too complex, then there are too many components that we risk fail, too many components that we risk leakage on. So don't include anything if it is not really needed. That's our message. Keep it simple if possible, and make inherent safety into the system where you can. And make it easy for the guys and the ladies who's going to operate it and maintain it. So, as soon as we start growing up and we need more energy, a few cylinders is not enough. We need much more energy on board. The example you see on this page is a typical coaster vessel in Norway that needs about 3,000 kilograms of hydrogen on board. Typical example like this. Again, it's not rocket science. Every component is available and you can purchase it, standard available. Even bunkering can be purchased. Finally, climbing up the ladders from the leisure craft to demonstrator crafts, let's go into the big boys, or the smaller of the big boys. The coastal cargo vessels, typically in Norway, the average age of the coastal cargo vessels in Norway is 28 years old ships. If we start fleet renewal for these ones today, it will be still 2, 3, 4, 5 years till they will start coming into the industry. But it will happen, and it is going to happen. And together with VAD and some other partners, we are into this program now where we are looking into how can we do it with a swappable container solution. So actually we're using the same transport containers as we are using for transport on road from production to the quayside, hoist it on board and use it as a maritime fuel storage container directly. From an economical point of view, the investors say that the business case is better that way. We have a lot of technical challenges because it has not been done. It hasn't been done before. So we need to find out, or we need to collaborate. We need to collaborate with the ship designers, class societies, the crane operators, everybody need to collaborate. Thank you. That's my story.
Thank you. And while the three former speakers are giving excellent presentations, thank you, all have products to show and to give to the market. Our next speaker, I hope this works now, the technology, does not have a product, but he has a boat. And let's stop for a second and give some credit to Joe Pratt, which is both CEO and CTO of Zero Emission Industries. Because he has not only kind of built the boat and made that happen, coming from a position as a researcher in the group and with his partners, but he has done that as maybe one of the first in the world. So I think the achievements that he have done here, that they together have managed, is tremendous. And I hope it works now, that Joe, that you are with us.
I am here. Can you hear me okay?
Excellent. It's all yours.
Thank you, Thomas, and thanks everyone for accommodating this remote presentation. Let me share my screen here. Great. Yeah, I'm going to be speaking today about the Sea Change, which is one of the first hydrogen fuel cell ferries. First, just a quick introduction. I'm speaking to you from Zero Emission Industries. We used to be called Golden Gate Zero Emission Marine. You may remember that name. We're a hydrogen technology company focused on simplifying the power system and all the hydrogen implementation on board vessels. We've also found other markets very interested in our solutions, and so that's one of the reasons for the name change, is to broaden our application space. Also, Zero Emission Industries is a little bit easier to say than Golden Gate Zero Emission Marine. So let me dive right into it. This is a picture of the Sea Change ferry. It was launched August 12th, 2021 this year. It's an aluminum catamaran, about 73 feet long, a 24.5-foot beam. The interior is configurable, but yeah, around 75 passengers. 22 knot top speed is the design. It's got two 300 kilowatt electric motors, 360 kilowatts of PEM fuel cell, and 100 kilowatt hours of lithium-ion batteries, along with 240 kilograms of hydrogen storage on the top deck, stored at 250 bar as pressurized gas. Just kind of pointing out some of the layout here. The fuel cells are in the aft compartment. On the main deck, there's a room that has all the fuel cells there. The electric motors, of course, are in the holes. The batteries are divided into two separate sections, about 50 kilowatts in each hole down in the bottom. And then the hydrogen is all on the upper deck. So one thing you'll notice is that there is no hydrogen below decks on this vessel. That's not prohibited by the regulation. It's just something that we thought for the first vessel, take advantage of the high dispersion properties of hydrogen and locate everything outdoors as much as possible. The vessel, you can see in the middle picture here, has a bow area, which is where passengers can embark and disembark. The aft area, currently, we aren't allowed to have passengers back there because of some of the overlaps with the hazardous areas. That may be something the owner tries to explore in the future with the Coast Guard to get an exception. Let's see, I'll go to the next one. In terms of fueling, you can see, let me show you, hard to see here, but on the top deck, there is a fueling interface. We call it our bunkering system. There is a hose here, and the idea is that the vessel can be fueled by any kind of a delivery truck. So it was important for us from the very beginning to make this as flexible as possible. So we don't have to install a $2 to $3 million hydrogen fueling station everywhere that this boat is going to dock. But it can be extremely simple. Wherever the boat shows up, a hydrogen truck, such as the one seen over on the right, can come and fill the vessel with a simple cascade fill. I guess we're pretty lucky in California to be able to count on this infrastructure because we have about 60 hydrogen fueling stations for light duty vehicles. So these trucks are running all over the state all the time. And essentially the same truck that fills the fueling station will be the truck that fills the boat. Some key milestones for the project. It officially began in June of 2018, but actually was conceived as an idea in summer of 2017. So it's been over 4 years since we thought of the idea to build this vessel. And for those of you familiar with some of my earlier work at Sandia National Labs, if you count the SF Breeze study, then we go back even a few more years. This project really came out of that paper study. As I mentioned, we just launched in August. We recently received the final approval from the Coast Guard for everything that has to do with all the hydrogen systems. So I am crossing my fingers and hoping we will have our first fueling before the end of the month. And then after commissioning at the shipyard is complete and we receive the certificate of inspection from the Coast Guard, we'll move it to the San Francisco Bay to begin operation, which should be on track for around January. So I was asked to speak about some lessons learned. I thought a lot about this. And to me, this is kind of what it comes down to. Partners, education and training, and hydrogen system expertise. And I'll talk about each one of those quickly. In terms of partners, when we're doing projects today in this uncertain area of hydrogen and fuel cells, and for people like me in hydrogen technology, it's not the technology that's uncertain, it's more about the acceptance and the regulation and getting everything to work together on the water. And that can take a long time, and it can be challenging. So what I've found the most valuable from our partners on this project is to have the vision and the patience to see the project through all the ups and downs and the unexpected duration and sometimes cost. So, for us, really BAE Systems, Hexagon, Hydrogenics, now Cummins, the shipyard, All American Marine, the owner, Switch Maritime, naval architect, Incat Crowther, they've been with us since the very beginning, and very understanding, flexible partners, willing to learn, and supportive the entire time. I would say that's the most important thing if you're putting together a project. Find the partners who you feel, they don't just tell you that, but you truly feel that they're going to stick with you through the whole thing. And also kind of on a practical matter, when you're trying to do something brand new, it's really hard to define a clear scope because there's going to be things that you don't even know you have to do. Try as much as you can to define that scope and plan for contingency more than you would a normal vessel. When we talk about education and training, there's two sides there. One is the personnel doing the work, the shipyard. We found that the typical shipyard does not have a lot of the expertise needed for installation of these systems. Everything from very high voltage electricity, which you would counter on even any battery boat. Some of the automation can be new. Of course, I haven't found a shipyard yet who has on-staff hydrogen piping expertise, going by the standards and all the requirements on that. Hazardous area electrical installations is, when you're looking at these small vessels, again, is pretty rare. And then dealing with high pressure and of course cryogenic can be very new. So I'm not saying that you can't do it, but again, this is where you can have a strong partner in a shipyard who's willing to learn and take on these things and understand what's expected. And then for the regulator side, it's as the people who are going to be reviewing your plans and your build of the vessel and finally the operation, it's really important that the regulators understand what you're doing. If they don't understand it, then they can't approve it. I've been working with the US Coast Guard since 2013, laying the groundwork for this type of deployment, starting in what I call baby steps. We started with a hydrogen fuel cell pure side project, which you can see a picture over here on the right. This didn't even get on the water, but it got the Coast Guard starting to think about hydrogen, helping them understand it by introducing them to experts in the field, even coming up with our own training course for local Coast Guard people. So it's really important to get the regulators up to speed, whether that's a state flag state authority or class or whoever you're using there, and make sure they're on the same page as you. And the earlier that can be done, I know everybody always says that, but the earlier it can be done, the better. Lastly, hydrogen expertise is critical in this project. That was our role. We did the integration of the hydrogen fuel cell system. We created the fueling system that I mentioned before, went through the safety systems, controls for the hydrogen system, and we were responsible for the regulatory approval of all of that. That's perfect for us because that's what we do. We approach our jobs from a hydrogen technology perspective, and anything we can do to make it simple for the operator, for the regulators, for the owner, that's our goal. The Sea Change is just one vessel. It's a small ferry. We see it as kind of trying to get through a forest that nobody's gotten through before and forging the first path. It's not going to be the best path, and we've learned a ton in doing the project. We know that other people can follow that path and probably take some shortcuts around places we've wandered around a bit. But it's going to make it in some way easier for any of these other vessels to now be deployed because of what we've been able to show with the Sea Change and get it through the regulatory process. And that's all I have for today. I appreciate your time, and I don't know if there is time or a session for questions, but if there is, I'm happy to stick around for that. Thanks.
Thank you, Joe, and that's great. Please stick around because I think we will do a short, quick Q&A session. Do we have any incoming questions, or we just take the room? Yeah. Are there any questions here in the room? This is your time. You have the manufacturers of the equipment, and you have one with unique expertise. I must say, Joe, if you're still with us here, that we are really impressed having seen what you have been able to accomplish. We have one question here. Do we have a mic for her?
Hi, hello there. I wondered if you could repeat the name of the yard you built it at?
Sure. That was All American Marine, and they're located in Bellingham, Washington.
Thank you.
Welcome.
One more in the room here.
Hi, while you're at it, could you tell us who the client is? Who's the owner?
Yeah, the owner is Switch E Maritime. I think I can't remember their website, but if you Google Sea Change and Switch, they'll come up.
And where will the ship be trading?
Be training?
Trading.
Oh, it's intended for commercial operation in San Francisco Bay. I don't know what the eventual plans of the owner are at this point, but that's the initial location.
Thank you.
Okay, one there before. Yeah. Lady first.
Yeah. Hi there. I'm Michaela Kendall from Adelan. We're a fuel cell company as well, solid oxide fuel cell company. I was interested in the panel's opinion. What do they consider the bottlenecks to be in the marine sector? What's the key bottleneck, if there was one that you could address? Thank you.
Do we have a mic? I think you're not on with your...
Am I on already? Yeah, I'm on. In my perspective, it would be, I think, the hydrogen infrastructure and the hassle owners now have to go through. It's possible to get your own truck, and like Joe does, and I know from owners like Future Proof Shipping, they can't be here, but they have to go to quite some hoops and finding somebody that can supply the hydrogen nowadays. But I strongly believe that if that hydrogen infrastructure or the supply is de-risked or is going to be installed, many maritime owners will step up and say, okay, well, if that hydrogen is already there or it's going to be there, I'll take the risk and I'll also start building the ship. So in my perspective, having the infrastructure there like the fuel is there now is the biggest challenge.
Johan?
Yes. Try to see if the mic is on. Is it?
Yeah.
No, it's not.
Not yet.
Try again.
Maybe it's
Johan's
on now.
mic.
It's coming back. No. Yes. No. So I was thinking this. I've been thinking quite a lot of this. What's the hand and the egg, and the supply chain and not. And I actually, if you look at you could start your own endeavor in this, and you can make your own mistakes, and you can start your own business in shipping, right? Go to Amazon, the guys, and hire up for cargo, and then you get finance. You can get it all together. There's tons of money in the wrong industries that has to flow over to this, so we don't have to focus so much on the hurdles. Yeah, the opportunities out there, and yeah, just get going.
I think to just comment on your comments again, I think you're right in what you're saying, and then as we have been discussing this morning, I think the logistics and having the full chain available, that's kind of where we are. Any other question? There was one there, yeah? You have the mic now?
Hello, Joe. This is Hans Tornell from Green City Ferries. I noticed on the vessel there's a pipe sticking up, way up in the air. Is that some kind of security thing or exhaust pipe or what?
Yeah, the large vent stack is one of the requirements of the IMO's IGF code for emergency venting of the tanks. There's a 10-meter set off to ventilation inputs, so that was one reason for that. The Coast Guard has indicated that that distance may be able to be reduced through the use of simulation. We didn't do that on this vessel. We just did what the IGF code required. But actually on this vessel and for future vessels, we're definitely considering the use of modeling in order to bring that height down.
Thanks.
Yeah.
Hi, I come from a PEM electrolyzer background, and one of the things that limits really large electrolyzers is the capacity of the stacks. Right now, PEM electrolyzers are kind of at the 1 or 2 megawatt scale of the stacks. So if you're talking about building a gigawatt scale electrolyzer, that's potentially 1,000 stacks, which is frankly ridiculous. PEM fuel cells are a bit further back in terms of scale. You're talking about hundreds of kilowatts. Where do you guys think you'll be in terms of maybe 5 years' time, 10 years' time, in terms of the size of your stacks?
Yeah, so basically, I think you're a bit wrong on the scaling thing, because actually the batteries are scaled to megawatt hours of batteries with exactly the same, or partly the same cells that are used in other industries. So at PowerCell, we are using the same cell, the same thing that is used in other applications on the maritime application, with some minor modifications, obviously. And from that scale, actually you're gaining the volumes from different segments, and you're capitalizing on that into another segment. So this is a paradigm shift, I would say, into maritime, that you're doing this. So this has to happen in order for the technology to be cheap enough to operate and to be serviced and to be maintained. Anything to add?
I can comment on that as well, but then I understand we are off the time, we'll limit her on the time limit, but basically the kind of the building brick of a electrolyzer being alkaline, for instance, is 1 ton per day. That's a 2.5 megawatt installation, including some compression and so on. And if you kind of want to scale that, the core electrolyzer, the cells, that's what's needed to be scaled. The other one can be scaled in 2 or 3 or 4 times that. And these companies are coming now that kind of will focus on that part. So they will be specializing in making the balsa plant and making that efficient. Okay, I think by that we have to close down this session. Thanks all, and thanks more to our fellow speakers.
So I want to thank our presenters, and particularly Joe Pratt for phoning it in. We are now having a coffee break that is hosted by Future Proof Shipping, who unfortunately weren't able to be here today. But before we go, I just want to thank our other sponsors. First, I can't say enough for Shift to Clean Energy. This is the new rebranding. So Brent Perry, our CEO, and also a co-founder of the Zero Emission Ship Technology Association, has really gone above and beyond to make this event happen. So first of all, I want to give a big round of applause to Shift and Brent Perry, without whom this never would have happened. And also to Bureau Veritas. We've got Nick Brown here from Bureau Veritas, again, without whom this never would have happened. So thank you, Nick. And you know what I'm going to do? I'm going to let you have your coffee, and then I'm going to thank all of our other sponsors later on, and not run you through a big long list of it. Let's all go have a coffee on Future Proof Shipping.